Hello friends, in this video we are going to discuss the performance parameters of inverters. Okay, so ideally speaking, an inverter should give a sinusoidal voltage at its output, right? But if you check the practical inverters, whatever we are having, or so far whatever we have discussed, these inverters are not giving the sinusoidal output, right? Those are giving the square wave output. Okay, it is a non-sinusoidal. Okay, so therefore, the performance of practical inverters can be evaluated in terms of the following three parameters. Okay, so which are those three parameters? Let us we are going to discuss. The first parameter is harmonic factor of nth harmonic. Harmonic factor of nth harmonic. Harmonic factor of nth harmonic, right? It is denoted with HFN. It is denoted with HFN. Okay, harmonic factor of nth harmonic. Okay, so this harmonic factor is nothing but it is a measure of the individual harmonic contribution. Okay, it is a measure of individual harmonic contribution in the output voltage of an inverter. Okay, so it tells us about the individual harmonic contribution, okay, in the output voltage. Individual harmonic contribution, harmonic contribution in the output voltage, in output voltage, that is a V0, right? In a output voltage, right? That is a V0. Okay, so HFN can be given as is equal to, yes, V0 n RMS value of the nth harmonic, right? RMS value of output voltage due to the nth harmonic divided by RMS value of output voltage due to fundamental component, right? RMS value of output voltage due to fundamental component. Okay, so are you getting the point, right? So it is ratio of V0 n RMS to V0 1 RMS, right? V0 1 RMS, right? So it gives the information about the contribution of respective harmonic, right, in the output voltage of the inverter. Okay, the second factor we are having is, yes, it is a total harmonic distortion, THD. Okay, so it is a total harmonic distortion, THD. Okay, so this parameter, yes, it is, it measures the closeness in the shape, right? It measures a closeness in a shape between the output voltage of the inverter, and its fundamental component. Okay, so it is a measure of closeness, right? It is a measure of closeness, it is a measure of closeness between V0 and V01, right? If you check, the nature of the V01 is sinusoidal, right? Nature of the V03 is also sinusoidal, right? Because whatever the V0 we are having, it is a square wave, right? And we are dividing it into the sinusoidal components, right? But with different frequencies. Okay, so it is a measure of closeness between the output voltage and the fundamental component output voltage. Okay, so it is given that total harmonic distortion, THD, is equal to, yes, it is under root summation over all harmonics, n is equal to 2, 3, 4 up to the infinity, right? But in our case it is like only odd harmonics. Okay, it is a V0n RMS square. Okay, so it is like V02 RMS square plus V03 RMS square plus V04 RMS square. In our case it is a V03, V05, V07, etc., right? Divided by, yes, divided by, it is a V01 RMS square, right? V01 RMS square. Is this clear? Okay, so are you getting the point? So this is the total harmonic distortion. So here if you check, in the numerator we are having, yes, in the numerator we are having The output voltage due to the harmonics only, right, divided by the fundamental component here, right. So further we can write, yes, further we can represent this as is equal to under root, yes, V0 RMS square, that is RMS value of total output voltage of the inverter, minus V01 RMS square divided by V01 RMS square, 01 RMS square. Okay. So further we can write it as, now this is output voltage minus fundamental. Okay. So this can be written as, yes, V0 RMS square, that is output voltage, divided by this term, so is equal to under root, we can write it as V0 RMS square minus V01 RMS square, right, divided by, yes, we can take this outside of the square root, so it is a V01 RMS. Okay, so this is the THD, total harmonic distortion, right. And the last parameter we are having the distortion factor. Third one is the distortion factor. Distortion factor. Okay, so distortion factor, it is the ratio of EF, is the ratio of fundamental RMS output voltage, that is a V01 RMS, divided by total RMS output voltage, that is a V0 RMS. Okay, so it is the ratio of fundamental output voltage RMS value divided by the total RMS output voltage of the inverter. Okay, so that is nothing but the distortion factor. Okay, so if the inverter is not having any harmonic, means the output is pure sinusoidal, then here we can say that V01 RMS is equal to V0 RMS. So DF is equal to 1, right? DF is equal to 1. Are you getting the point? Okay. Next, if inverter is having a pure sinusoidal output, okay, then in this case, yes, the harmonics will be absent. Okay, so summation of the output voltage due to harmonics, it will be 0. Okay, so THD will be 0. Okay. Next, what is the HFN? If the harmonic is not present, so therefore HFN will be 0. Okay, so these are the three parameters on which the performance of the practical inverters, right, are judged or can be evaluated. Okay, so in the next video we are going to discuss numerical related to the performance parameters of the inverters. Thank you.